Hello my dear students, let us start our today's class. Today we will discuss Newton's third law of motion. Among these three laws of motion, the statement of the third law of motion is the simplest one, but it is very much conceptual. Now what is the statement? To every action there is an equal and opposite reaction. Now let us try to understand this law. Now just consider when we apply any force on a wall with our hand, we also feel some pressure on our hand. Here which force is the action and which one is the reaction? See, first we apply the force on the wall. So first we apply the force on the wall. So this is the action which acts first, and immediately after we apply the action, the wall also apply the reactional force on our hand, which we can feel. So which force we are applying on the wall, that is the action, and the wall is applying the reactional force on us. That is, so immediately we apply the action, the reaction developed. Now here we will remember some important points. Third law of motion. First we have to remember action and reaction forces are equal in magnitude. Means their value are same in amount, but they are opposite to each other. So their magnitude are same, but they are opposite in direction. Next, you have to remember action and reaction act on two different bodies. See, for our examples, action was applied on the wall, but reaction was applied on our hand. So always action and reaction acts on two different bodies. Next, first action is applied on the second body by the first body. Immediately the reaction is developed and applied to the first body by the second body. So always action is acted on a particular object by some other object, and immediately reaction are developed and that is applied to the object who creates the action. Clear? Now let us discuss some examples related to Newton's third law of motion, which will help us to understand the law very clearly. First, consider walking of a person. See, when a person walks on the ground, he pushes the ground with his foot on the backward direction by pressing the ground. This push is known as action. And according to Newton's third law of motion, an equal and opposite reaction acts on the foot of the person by the ground. And this reaction force of the ground on the person pushes him forward. So what is action here? Action is force exerted on the ground by a person through his foot. And what is reactional force here? Force exerted by the ground on the person. Okay. Next, consider how a ball rebounds after striking against a floor. See, when a ball strikes against a floor, it exerts a force on the floor, which is action. And according to Newton's third law of motion, the floor also exerts an equal and opposite force on the ball, that is reaction, and due to this reaction the ball rebounds. So here which force is actional force? Force exerted by ball on the floor, which acts fast. And what is the reactional force? Force exerted by the floor on the ball. Now just think, how do we swim? See, while swimming, a swimmer pushes the water backward with his hand, and this is the actional force. And the reaction offered by the water to the swimmer pushes him forward, which is reactional force. So here action is the force applied by the swimmer on the water in the backward direction, and reaction is the force exerted by the water on the person in the forward direction. Now just think what happens when a person jumps out of a boat. See, while a person jumps out of a boat, he pushes the boat on the backward direction with his feet, and this is action. And according to the Newton's third law of motion, the boat also exerts an equal force on the person, which is reactional force. And due to this reactional force, the person jumps out of the boat, and due to the action on the boat applied by the man, the boat also moves backward. So here action is the force applied by the person on the boat, due to which boat also moves backward on the water, and due to the reaction applied by the force on the person jumps out from the boat. Next, just consider when a bullet is fired from a gun, the gun recoils, means it moves backward. Why? See, when a bullet is fired from a gun, force is exerted on the bullet by a spring in the gun, and the bullet accelerates in the forward direction. And according to Newton's third law of motion, an equal and opposite force is exerted on the gun, and the gun accelerates in the backward direction due to this force. The force exerted on the bullet is known as the action here, and the force exerted on the gun is known as the reaction. And due to this reaction, the gun recoils. Now just think, what is the explanation of the motion of rockets and jet aeroplanes? This also we can explain with the help of Newton's third law of motion. Now see, the rocket or jet aeroplane's engine expels hot gases which produce due to the burning of fuel, and with large speed in the backward direction from its rear end. And according to Newton's third law of motion, an equal and opposite reaction acts on the rocket, which pushes the rocket in the upward direction. Okay, so this is the explanation of the motion of rockets or jet aeroplanes. Now we can explain more practical situation with the help of Newton's third law of motion. Now here I am uploading one video which will help you to understand more clearly the Newton's third law of motion. And this much is for today. Thank you.
Till now, we've only learned the first and second laws of motion. Oh, you're riding a bicycle. Have you ever wondered why a bicycle moves forward? Well, it moves according to Newton's third law, which says that for every action, there is an equal and opposite reaction. To understand this, see what happens when you drop a tennis ball. As the tennis ball hits the floor, it causes a downward force on the floor. This is the action. The floor reacts by pushing on the ball with the same force, but in the opposite direction. Action, reaction. Together, the floor and the ball form what's called the action-reaction pair. So now how it applies to your bicycle. When you push the pedal, the parts of the tire which touch the ground push it backwards. The ground also pushes the tires forward with the same force. So the parts of tires and earth form a pair of action and reaction. So what happens to the earth when your tires are applying force to push it backwards? Nothing happens to it, since the earth is very big as compared to your bicycle. The force applied by your tires does not move it backwards, but force applied by the earth pushes your bicycle forward. So now you understand Newton's third law. Yep, the tennis ball is the right example. The ball and the floor are creating a pair of action and reaction.
Examples to illustrate Newton's third law of motion. How do we walk? When we walk on the ground, our foot pushes the ground backward, and in return, the ground pushes our foot forward. Why the cannon recoil? When ball is fired from a cannon, the force sends the ball forward and is equal to the force sending the cannon backward, hence the cannon is said to be recoiled. Jet aeroplanes and rockets. The action of the gases downwards of the rocket gives equal and opposite reaction to the rocket to move upward with great speed. The case of hose pipe. The fireman directs a powerful stream of water. They hold it tightly because it has tendency to go backward due to the backward reaction of water rushing in forward direction.